Calling all 3D printer experts. I've been doing some stained glass prints. This is 3 layers at 0.2 millimeters per layer. By the way, that's with a 0.4 millimeter nozzle. I wanted to make really cool stained glass designs for something as small as a guitar pick, so I am using a 0.2 millimeter nozzle for this. This was my first design. This is printed out in petg carbon fiber, and it works really well. Then I started getting into the transparent petg prints to get a stained glass kind of effect. This one's just the first one I did with a really large stained glass area. Then I moved on to a more intricate design. That's 0.1 millimeter layers for the leading on the stained glass and 0.1 millimeter layers on the glass itself. This one had a layer shift, so it's kind of double printed. After changing some settings, I seem to get it down. This is 7 layers on 0.1 millimeter per layer for a total of 0.7 millimeters of a stained glass guitar pick with 0.1 millimeter layer lines. However, the surface texture of this is a little rough. I think you can hear that. And I didn't know if guitarists would want to hold it like that and have a little bit of roughness on their hand or not. Actually, it feels kind of good to me, but I wanted to see how smooth we could get this top layer. So I started off with the basic ironing settings. This is like 30 millimeters per second, 10% infill, and I used concentric on this one. You can see there's a little bit of refraction of light going on right here because it created a little bit of bubbles. Same on the other one, but the surface is a lot smoother. I think you can tell based on that sound. So then I did what any sane 3D printer would do. I'm going to run a test and try out a bunch of different flow settings on the ironing to see what happens. I had 5% flow, 7.5% flow, 10% flow, 12.5% flow. Don't know where that one went, but I ran a 15 and a 17.5% flow. But when it came to taking these off of the build plate, a flex build plate by the way, they just pretty much disintegrated, like actually crumbled to little pieces and bits, like that. Now the 5% and the 7.5% flow came out the build plate just fine, like I had taken them off before, no problem. But what's really weird is the 10% didn't, and anything above the 10% was just really bad, although the 17.5 actually stuck together a little bit better. Kind of weird. So that was a little concerning because you don't want a guitar pick crumbling in your hand. It has to have some elasticity. So I ran a test on my original stained glass picks. This one is the concentric infill pattern at 10%. It snapped in half. And this was the rectilinear infill pattern at 10%, and it also separated. But the no ironing pick bent 180 degrees to match up and did not fall apart. I also tested this one. It bent over all the way to edge and did not break. I couldn't say the same for the original guitar pick I had. You bend it once, it breaks. Kind of crazy. But I wanted to know if anybody had any ideas why, when you increase the flow percentage on your top ironing, it might cause something like a stained glass guitar pick at a 0.2 millimeter nozzle to completely break apart into tiny little pieces. It like loses all of its bendability. This one didn't do it. No ironing. So I'm interested to hear why you think this is happening. This one is a petg carbon fiber pick. Doesn't seem to have that problem, and it's carbon fiber made. So, what do you got for me?